Hello, I'm Roman. Welcome back to a series of the videos Learning Go, where we dive into a tour of the Go together and learning some basics on the language. Today the video again will be short, and one of the things that I'm still having a cough to the cold, and I want to spend a little bit time editing the video about the neural networks from scratch series. I finally recorded, but it's hard for me to talk a lot like without interruption. So hopefully I will manage to talk about Go language for at least 30 minutes. So let's go. So let's not waste our time. So currently we're at exercise slices. Basically, the exercise is I need to implement a function called pick, which is, I think, the shorthand from the picture, to return a slice of length dy, each element of which is a slice of dx of 8-bit unsigned integers. When you run the program, it will display a picture interpreting the integers as a grayscale, well, blue scale. Not sure what it is. Values. The choice of image is up to you. Interesting function includes x plus y divided by 2, x multiplied by the y, or x in power of y. You need to use a loop to allocate. Use wind cast from int value to convert between types. Not sure. Okay, so we need to create a result which should be we're going to use make, and it will be int 8, and that should be the length of the d, right? And then we'll return it. Then we need to go over the range, which will be the results. I mean, I can use the normal for loop, but that should be okay too, because we are taking the index only, and I need to allocate second row results at I equal to make and by the size of dx, right? And then I'm doing this one, but instead we'll use j, and that should be this one. So what we're doing, we are slicing. We're accessing the first slice, then the second, then it's an element in the slice. And what we're doing, what is the x plus y dx? Okay, so this is basically I plus j divided by 2. And I think that will be an integer, so we will typecast it, right? And it should work. Oh, nice. Okay, this is the gradient. Oh, okay, so they treat this not a grayscale, but as shade of blue. What else we can do? This one, right? What it will be? Cool. And the last one is this one. Interesting. Okay. And what if we'll do this? Yeah, I think it's... All right. Then we can go next. Maps. Or in some languages it's called dictionaries, but I prefer the maps too. But okay. A map maps keys to values. Zero value of map is nil, and nil map has no keys, nor can keys be added. Okay, so it's not like the map has the size of the 0, it's actually a nil. The make function returns a map of the given type, initialized and ready to use. Let's take a look. Okay. But I guess can we print the whole map? Right? Okay, so this is the whole map, and what if we will... Oh, I missed the vMotions. Here should be nil. It actually returns the zero value of the map is nil. And nil map has no keys. Oh, maybe if it will be, you know, like fm map from string and vertex. Maybe this will result into nil? No. Okay. Then I don't understand this line, to be honest. Because, for example, with the slice, it will, you know, actually be nil. Because if, for example, we do this and then print the slice, right? Then that will... Oh. Okay, then I don't get it. Oh, but maybe it's an issue, not an issue, maybe it's the way it prints it. Let me try this. If we go to nil, right? Okay, so with the make it's not nil, but if I will write like this... Okay, and that should be the same with the slice, so I actually can check with the new value. Okay, now it's clear. Map literals. Map literals are like struct literals, but the keys are required. Oh, okay, so we can create and initialize the map right away. Map literals continued. If the top level type is just a type name, you can emit it from the elements of the literal. If the top level type is just a type name, you can emit it from the elements of the literal. Okay, so basically we're calling the constructor of the vertex, this one, without actually typing the name, because I think, you know, that should be the same. Yes. Okay, mutating maps. Insert the update element in the map, just square brackets by the key. Retrieve an element, same. Delete an element, there is a special delete function, okay. Test that a key is present with a 2-value assignment. Okay, so here, like, if it's... if k is in M, awk is true. If not, awk is false. If k is not in the map, then lm is the 0 value of the map's element type. Note, if lm or ok have not yet been declared, you could use a shortcut. Oh, okay, so wait. 42, okay. Then we delete it, and if we just accessing it, it returns the default value. Okay, can I do this? So I would make better understanding. Yeah, you cannot use 42 untyped in const. That should be like this, right? Okay. Yeah, so the default is okay. Yeah, in that case, for example, in the Swift with the dictionary, you can do this and it returns an optional type. So for example, if it was like this, the dictionary as well, string and the int, when you access the element, it converts this one into an optional one. But okay, since there is no like optional, like in Swift, it will return nil, but here it will return the default value for this. And yeah, you need to check for the oak variable. Okay. Maybe it's actually, I mean, like optionality in some ways is a very good concept, but sometimes it's too much optionals everywhere, and like you do a lot of the optional chaining check and etc. Example, implement word count. It should return a map of the counts of each word in the string S. The word count test function runs a test suite against the provided function, prints succeed fail. You might find strings of fields. Field splits the string S around each instance of one or more consecutive white space characters as defined by Unicode displays, returning a slice of substrings of S on an empty slice if it contains only one unspoken. And what should I return? Okay, implement what card to return a map of the, okay. So we have, okay, what do we have now? Downloading, okay. No new variables on the left side. Okay. Not sure that's word. If there is word, then we have M, and okay, basically, wait, so this is just world plus 0, 1. That's it? Or am I missing something? Pass. Okay. Yeah, basically what I had to do is just so you might find strings.fields. Okay, so fields, maybe this, that should be the same, right? No. Strings.fields s, this one. Okay, this is the same. Okay, so instead of splits and defining the space, we actually could have a function that does something, or not something, the same. Okay. Function values. Functions are values too. They can be passed around just like other values. Okay. Function values may be used as function arguments and return values. So you can take a function as an argument and you can return a function. For example, okay, actually didn't use this syntax, but I guess I can create an in-place function. So for example, if there is a function that is used in only one place, probably there is no need to create it as a separated function or a method of the struct. Okay, so we declare a function with the two types, with the two float64 input params that returns another one, and then we can pass it into the compute. Okay, so we have the compute that calls the function that we pass with the parameter 3 and 4. For example, in this case, it will be powering the 3 into the power of 4, which is this value, with the compute hypod. And okay, so it takes the square root from 9 plus 16. Okay, 25. Okay, that's 5. I just didn't see the t here. Function closures. Okay, Go functions may be closures. A closure is a function values that references variables from outside this body. The function may access and assign to the reference variables. In this sense, the function is bound to its variables. Okay. For example, the add r function returns a closure. Wait, it returns a closure. Each closure is bound to its own sum variable. Oh, okay, so it returns the function and it bound to its own copy of the sum. So we have the positive and negative, and they kind of okay. So it's reference the sum. It makes kind of the copy of the sum. Interesting. What if it will be like this? How it will capture? I think in that case they will capture the same, right? And -1, but before it was, yeah. So they actually reference in the same. So I need to keep in mind where exactly and how exactly the variable was created, and it looks like it actually references the specific instance of the variable. I mean, for example, in the Swift, you could have like there are closures, but they have two ways of capturing the variables, by the reference or by the copy. So for example, you can capture the value at the time when the closure was created, or you can reference the original variable, and once the closure is called, it will reference the actual value. But there is only one approach, and I think it might, you just learn there is one way, and that's it. Okay, let's have some fun with functions. Implement a Fibonacci function that returns a function that returns successive Fibonacci number. Okay. Fibonacci is a function that returns a function that returns an integer. Okay. Implement a Fibonacci, but implement a Fibonacci function that returns a function that returns successive Fibonacci numbers. I'm not sure what I need to change here, to be honest, because there is a function, and every time you call it, it returns the next Fibonacci sequence. What? It returns a function that returns successive, but I mean, it's implemented, right? No? I'm really not sure what else I should do here. Congratulations, you finished the lesson. You can go back to the list of models to find what to learn next or continue with the next lesson. So what will be the next lesson? Methods and interfaces. Okay. Methods. Go does not have classes. Simple as that. However, you can define methods and types. A method is a function with a special receiver argument. The receiver appears in its own argument list between the func keyword and the method name. In this example, the ABS method has a receiver of the type vertex named v. So we have a type. We have the ABS function that is attached, well, it's called attached to the vertex. And the main thing is that this is how you call the variable that you're going to use inside the function, and you can reference the same vertex. Why it's not formatted? Yeah, so 5 value. Okay. Remember, a method is just a function with a receiver argument. Here's a base written as a regular function with no change in functionality. Yeah, so you can move this here, and the only thing that's the way you call it. So right now there is an ABS function that takes vertex, but here's the problem. If you, for some reason, need the same name for the function, but for the different types within the one module, you cannot do this because what? Go doesn't have the function overloading. For example, I cannot, oh, shift enter. So I cannot do this, like value in float 64 return, I don't know, something stupid, but just to show the point. ABS is already declared in this block, but if I will do this, value int, right, and then I will do the vertex. Okay, the ABS and I don't know, 10. Unexpected name ABS in the argument leads 23. Okay, maybe I can do this specifically, but anyway, cannot define. Oh yeah, cannot define method on there. Okay, type. Okay, let's call it my int extract, and that will be value int, and that will be my int. Well, right? Can do this. Okay. And then I want to do something like my int 10. Yeah, so this is what I want to show. That right now I could have the two ABS methods. And that's okay. But vice versa, I could not have the same like global function, well, not the global, but I mean the function in the same namespace, like in the model with the same name. Let's go. Methods continued. Okay, probably I will. Okay, just one more, and I will stop for today, as I kind of seems like I need to go. Okay, and there is one pointer receivers. Good way to stop right now. Methods continued. You can declare a method on non-struct types too. Okay, in this example, we see a numeric type myFloat with an ABS method. You can only declare a method with a receiver whose type is defined in the same package as the method. You can declare a method with a receiver whose type is defined in another package, which includes... Yeah, this is, I mean, this gave me a little bit of headache on the neural networks from scratch series. Once I had to implement the JSON marshalling because the Golang doesn't provide the marshalling in the JSON. I mean, that's expected because there is no, like, you won't do the marshalling of this type of the data in the JSON, but for me it was like storing in the JSON was easier so I can check it, you know, with my eyes. But this is, I really don't understand what are the consequences and why I cannot declare, to this. But I mean, okay, it's their language. But that's the only thing that I, had troubles with before. But maybe with the typecasting, like the type alias, I would solve my problem. I'm not sure. Okay, so this is... But I guess the compiler will treat it like a different, no? Just indicate my float, FABS. Okay. Okay, almost 30 minutes of recording. I will stop for today. As I want to spend some time checking the editing of the neural networks from scratch video for the main channel. But hey, look, I think, okay, we finished with the basics. there is methods in the interfaces. There is no like 1, 2, 3, 4, 5 exercises. Okay, so this is interesting. I think tomorrow I will go up to the exercises for the stringers, and then do the rest. And I think the interesting part will be with the generics and the concurrency, which still I will probably start this week, but most of the things will happen next week. Yeah, I think this is where we will spend most of the time playing with the generics and more specifically with the concurrency, because the Go concurrency, working with the channels, is something new to me. So that might be interesting. Okay. Thank you for watching and see you tomorrow. Bye bye.